Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.5, day 1, entitled Inverse Trigonometric Functions and Their Graphs. Now we're not actually going to be graphing in this section. We're just going to be looking at the inverse sine and cosine and tangent functions. So we're going to be doing a little more algebra for this section. And the inverse functions, remember, is where they're written with f to the negative 1 to show that they have an inverse. So the inverse sine and cosine and tangent functions are going to have that little sine to the negative 1, or cosine to the negative 1, or tangent to the negative 1. So they look like this on your calculator. There's little buttons for them. Okay. Now remember that for a function to have an inverse, it has to be 1 to 1. Now most of our trigonometric functions, they're types of curves, so they don't necessarily follow the 1-to-1 rule because they don't pass the vertical line test. Okay, they have to pass the vertical line test, VLT, the vertical line test. And they won't do that unless we restrict their domain. So that means we're just going to look at a certain part of the sine function or a certain part of the cosine function so that they will pass the vertical line test. Okay, so let's take a look at the sine and cosine for today. Tomorrow, or for in the next section of notes, we'll take a look at the tangent. But just for the sine function, there's a lot of different ways that you could restrict it. Basically, we have a curve. I think there's a diagram coming up on the next page. Okay, this is a sine curve and it keeps repeating and repeating and repeating. So we can go anywhere on that curve. Okay, but the easiest way to restrict it, natural way, as the slide says, is to restrict the domain from negative pi over 2 to pi over 2. Okay, and the reason we want to do that is because that will make the sine function 1 to 1. And we get each of the values in the range on this interval. So when we take a look at this picture here, if we just have this picture, and we drew our vertical line test, or I'm sorry, horizontal line, to check the horizontal line test, you can see that this horizontal line touches our function several times. So when the sine curve is just continuous like this, it doesn't pass the horizontal line test. It's not 1 to 1. It doesn't have an inverse. But if we restrict it, if we just chop off a little piece from negative pi over 2 to pi over 2, this little piece right here, from there to there, if we just take that little piece, then we have this nice curve where if we draw a horizontal line across it, that horizontal line is only going to touch that graph at one time, no matter where we put that horizontal line. So when we're dealing with inverse sine, we have to make sure that we're staying between negative pi over 2 and pi over 2. And that's explained a little bit more here. Okay? Oh, that's just another picture of it. Here we go. Okay? So we want to have a domain for our inverse sine functions of negative 1 to 1. That means those x values that we're putting into the function are going to be between negative 1 and 1. And the range, the values that we get out, our answer, is going to be between negative pi over 2 and pi over 2. Now if you're thinking of the unit circle, okay, here we have pi over 2 and here we have negative pi over 2, which is, oops, 3 pi over 2. Okay, so we want to stay in these values on the unit circle when we're looking at our sine and our inverse sine functions. Okay, and sometimes this is also called the arc sine. They throw this vocabulary word in there as well. So the book or even a quiz or a test might say, find the arc sine of a certain value. Just remember that that's the same thing as the sine to the negative 1. And the way that it's written here, okay, remember we're basically finding the sine of some value that's going to equal what they give us. Okay, so when we're doing the sine to the negative 1 of x equals y, okay, we're actually finding the sine of y that will give us x. Okay, so remember for inverses, those x and y's, they flip-flop their locations. Okay, and a really good way to describe that then is that y equals sine to the negative 1 of x is the number in the interval negative pi over 2 to pi over 2 whose sine is x. Okay, so I'll explain how we're going to think through this and how we're going to write this when we do our examples coming up in just a moment here. Okay, now we're going to talk about these cancellation properties as well. We'll talk about those in example 3, but there are some instances where if you're dealing with the sine of a sine to the negative 1, so the inverse sine, if your x value here that you're taking the inverse sine of, if that is between negative 1 and 1, you can just cancel out the sine and the sine to the negative 1, and x will be your answer. Okay. And if it's flip-flopped, where you're taking the inverse sine of a sine of x, if this x value that you're just taking the normal sine of, if that is between negative pi over 2 and pi over 2 on the unit circle, then again, you can just cancel those values and x will be your answer. So that's a little bit of a shortcut that we want to be aware of and pay attention to because that can save us some time. Okay. Now you can still work through the problems and get the correct answer even if you don't remember these cancellation properties as a shortcut. But it all deals with the domain and the range and how we're writing the equation, where we're taking the original function and then the inverse function. Okay, so this is what your homework problems are going to look like. They're going to be written like this. They're meant to be straightforward. They're meant to be easy. Okay, but you do have to do some thinking about where your values are. Are they between negative 1 and 1? And are they between negative pi over 2 and pi over 2 for those domain and range values? Okay, so here we have, whoops, we have the sine of negative 1, or the inverse sine of 1/2. So very first thing I'm going to do is I'm going to think, okay, this value that they gave me, this 1/2 value, that has to be between my domain. Okay, this is my x value. Okay, so I have sine to the negative 1 of x, basically. Okay. So this value here, this 1/2, this has to be between negative 1 and 1. Okay. And it is. So 1/2 is between negative 1 and 1. Because that's where our domain has to stay, between negative 1 and 1. So if that happens, this value that they give you is between negative 1 and 1, then you're good to go on to the second step in this thought process. Okay? And that thought process then is to rewrite the equation just a little bit. Okay? So what this means is that we're trying to find the sine of something that gives us 1/2. Okay? So this is the inverse sine of x, but remember when we rewrite it, when we do the inverse of the inverse sine, we get sine, and when we rewrite it, we flip-flop our x and y around. Okay? So this 1/2, that was the x up here for the inverse, is now the y for our traditional sine function. Okay? So just think the sine of something is 1/2. So now we basically have to look on our unit circle. And when we're on our unit circle, remember, we need to stay between pi over 2 and negative pi over 2. So we need to stay on the right side of this unit circle in the first and the fourth quadrants. Okay? So I need a location on my unit circle where sine is 1/2. It has to be a positive 1/2. So we're going to look at our ordered pairs here. We're going to look at our terminal points. And remember, the ordered pairs are cosine and then sine. So I want to look at my y values. All of my y values down here are negative, so I'm not going to be down in the fourth quadrant. I will need a positive 1/2 right here. This terminal point gives me a sine value of 1/2, and that radian is pi over 6. So my answer is pi over 6. Okay, so my answer has to be the radian value that is between negative pi over 2 and pi over 2 on my unit circle. Okay, so let's go through this thought process again now. For part B, I have the inverse sine of negative 1/2 now, instead of positive 1/2. Okay, so I have to ask myself, okay, is this negative 1/2, is that between negative 1 and 1? Yes, it is. Okay, so my negative 1/2 is between negative 1 and 1. Now that's not really something you have to write down every single time. I'm just kind of showing you the steps in the thought process. So now I'm going to rewrite it. Okay, so this I would definitely write down. I would write down sine of something gets me negative 1/2. That's what I'm really trying to figure out when I'm dealing with the inverse sine. I took the sine of something and I got this for an answer. So now I take the inverse sine of my answer and I'll get that something back again. So this part for sure you definitely need to write down when you're dealing with these problems in homework or quiz or test. The part with the little star, you don't have to. That's just a mental thought process. Okay? So now I'm going to go to my unit circle. And remember, on the unit circle, we have to stay between pi over 2 and negative pi over 2. And now I want a value, a sine value, that is negative 1/2. So in my ordered pairs, remember the y is my sine. So negative 1/2 is right here, and that is 11 pi over 6. So that's my radian measure, 11 pi over 6. So if I take the sine of 11 pi over 6, I get negative 1/2. If I take the inverse sine of negative 1/2, I get 11 pi over 6 back again. Now, you could also write your answer as negative pi over 6. It's probably preferable to have the positive values for your answer, but if you write down 11 pi over 6 and you check at the back of the book and they have negative pi over 6, remember that those are the same location on the unit circle. Okay, same terminal point. So I would accept either one of those. Okay, part C now. I'll go through this one more time. I'm going to take the inverse sine of 3/2. Now again, I have to ask myself, is this value, this 3/2, is that between negative 1 and 1? Okay, now 3/2, remember, that's really 1/2. So this is not between negative 1 and 1. Okay, so this means that I'm not going to be able to evaluate this. You could do this on your calculator if you wanted to. You could try it out. The sine button, if you look above it, if you do second sine, let me get out of y equals. If you do second sine of 3 divided by 2, it gets you an error message. Okay? That's because you cannot take the sine of something and get 3/2. Okay? So this is undefined. Remember, on your calculator, you want your calculator to be in radian mode. So go to mode and check that radian is selected. If not, arrow down and then hit enter so that the radian mode is selected. Okay? Okay, so let's keep moving here. For these, for this example, it says evaluate the expression with the inverse sign, but notice that we're taking the inverse sign of a sign. So this is where we've got those cancellation things going on. Okay, we're taking the inverse sign of a sign right here. Okay, so I want to see if that value that they gave me is between negative pi over 2 and pi over 2. So that's going to be my first thought process. If that value is between negative pi over 2 and pi over 2 on the unit circle, then I can just cancel. If not, then we'll have to evaluate it in a more traditional method. Okay, so let's take a look here at part A. We have the inverse sign of the sine of pi over 3. So this pi over 3, this is what I want to think about being between pi over 2 and negative pi over 2. And if we look at our unit circle, pi over 3, pi over 3 is right here. So it's between pi over 2 and negative pi over 2. Okay, so we're good to go. So pi over 3 is between negative pi over 2 and pi over 2. So when that happens, when you have that betweenness, all you have to do is cancel those out, and you get pi over 3 as your answer. So when you're taking the inverse of a sine, then you have to make sure that your value is between your range values of negative pi over 2 and pi over 2. Okay, so let's take a look at part B now. We'll go through the same thought process. I'm going to look at this value of 2 pi over 3, and I'm going to see if it's between negative pi over 2 and pi over 2. Okay, so here's negative pi over 2 and pi over 2. I'm dealing with 2 pi over 3. Whoa, 2 pi over 3 is over here. Okay, so I can't just cancel. So 2 pi over 3 is not between negative pi over 2 and pi over 2. So I cannot just cancel these out and get 2 pi over 3 as my answer. Can't do that. But I can evaluate the sine of 2 pi over 3. I can figure that out on the unit circle. Okay, this you should have memorized, the sine of 2 pi over 3. If you don't have it memorized, well then go to 2 pi over 3, and the sine value is going to be square root 3 over 2. That's what the sine of 2 pi over 3 is. Okay, or you could say, oh, 2 pi over 3, my reference angle is pi over 3, and in the first quadrant, that terminal point has a sine value of square root 3 over 2, and even in the second quadrant, it's positive. So that thought process that we've been doing throughout the whole chapter now still applies. Okay, so all I'm going to do here is I'm going to evaluate the sine of 2 pi over 3. And that we did. And we got square root 3 over 2. So now I have an expression similar to what we did in our previous examples here, the inverse sine of some measurement. Okay, so I'm going to go through the same process we did before. Okay, square root 3 over 2. The square root 3 is 1.73. Divided by 2 would definitely get me a value that's between negative 1 and 1. Okay, so this square root 3 over 2 is between negative 1 and 1. So I can go ahead and evaluate this. So I'll have the sine of something gets me the square root 3 over 2. Now again, that something has to be between negative pi over 2 and pi over 2 on my unit circle. So the square root 3 over 2, I need a sine value that's square root 3 over 2. Again, remember, sine is the y values, so all of these down here are negative. So I'm going to go up here to my first quadrant, and the y value that's square root 3 over 2 is right here. And that corresponds to pi over 3. So my x value is pi over 3. Now, even if for part A, if you couldn't remember those shortcuts for canceling, you could still go through this thought process here. Okay, you could say the sine of pi over 3, here's pi over 3, the sine of that is square root 3 over 2, okay? So the inverse sine, the sine of something, has to get me square root 3 over 2. Well, that means I took the sine of something and I got the square root 3 over 2. Well, here's the sine value, square root 3 over 2, and that radian measure is pi over 3. So if you go through that thought process, you just kind of go in a little loop there when these cancel. But you can still go through the same thought process that we did in part B. It's just that you're kind of staying in the same spot on the unit circle and just kind of rotating back and forth between the radian measure and the terminal point. Okay, so let's try this now for the cosine function, and then we'll be done with this section. Okay, now the cosine function, again, it's a big wave. The cosine curve looks like a big wave. It keeps repeating. So if we tried to do the horizontal line test, it wouldn't pass. Okay? This horizontal line is going to touch the graph at numerous points. Okay, so we have to again restrict our interval for the domain of this function so that we make it one-to-one. And right up here, we're going to restrict that domain from 0 to pi. So we're just going to chop off this part of the graph right here. Okay, so from 0 to pi, now I have a function where if I draw a horizontal line, it's going to touch the graph just one time, so it passes the vertical line or horizontal line test. So now we have a one-to-one function. We can deal with our inverse values, okay? And we can find all of the values we need just within this domain. We'll be able to find all of our range values. Okay, so you have to remember now that cosine, you have to stay between 0 and pi. Okay? Now again, our domain is going to be from -1 to +1, okay, just like before. But now when we're looking at our unit circle, we have to look for those range values that are between 0 and pi. So now on our unit circle for cosine, we want to go from 0 to pi. So we're looking at the first and second quadrants in our unit circle. For sine, we were staying in the first and fourth quadrants. But now for cosine, we're looking at the first and the second. So it's a little bit of a shift now. Basically, that's the only difference between these two processes. Okay? And we do still have our cancellation properties. Okay? And they're listed right here. So again, if you can remember these shortcuts, great. If not, that's okay. You can still think through the process like we did in the previous slide. Okay? But if you're taking the cosine of an inverse, then that x value has to be between -1 and 1, which is your domain. If you're taking the inverse cosine of the cosine, then your x value has to stay between your range values, between 0 and pi. So if that happens, then you can just cancel and x will be your solution. Okay, so let's take a look at our examples here. Example 4. We're dealing with the inverse cosine of square root 3 over 2 for our first part here. Now we're still going to ask ourselves, okay, is this value here, the square root 3 over 2, is this between -1 and 1? Now again, square root 3 is 1.73 divided by 2 gets you a decimal that's between -1 and +1. Okay, so yes, the square root of 3 over 2 is between -1 and 1. So that means I can go ahead and I can work through this problem. Okay, and then I'm going to rewrite it just like we did before. So I'll have the cosine of something got me square root 3 over 2. So now I just need to think, okay, on my unit circle, in the first two quadrants, the cosine of what radian gets me the square root 3 over 2? So remember, I want to look at my x values now in my ordered pairs because that's my cosine values. Over here, the square root 3 over 2 is going to be negative. All of these cosine values, all those x values are negative in the second quadrant. So I'm going to go back to the first quadrant here. And the square root 3 over 2 corresponds to the pi over 6. So x is pi over 6. Okay? Same thought process as before with the sine functions and the inverse sine functions. You're just looking at the top two quadrants on the unit circle instead of the right two quadrants on the unit circle. Okay, part B, the inverse cosine of 0. Now hopefully you know 0 is between -1 and 1, so we can go ahead and do this. Okay. So 0 is between -1 and 1. This problem is doable, so now we'll rewrite it. The cosine of something got me 0. So what something, what radian measure on the unit circle has a cosine or an x value in their terminal point that's 0. So if we need to, let's look at our unit circle here. The x that's a 0 is going to be right here. In my ordered pairs, the x value that's a 0 is right here. So the cosine of pi over 2 would get me 0. So x is pi over 2. Okay, and in part C, the inverse cosine of 5 over 7, just 5/7. Now, here's the thing with this one. 5 over 7 is not a nice spot on the unit circle, okay? We could find it. We could chop up this top semicircle into 7 sections, and we could go 5 of them, okay? But it's going to be a decimal, all right? So for this problem then, we want to go to our calculator. So we're going to do the second cosine of 5 divided by 7. And we get a decimal here. Then you want to round to 4 places. And again, make sure your calculator is in radian mode. Okay. So this one, this 5 over 7 is definitely between -1 and 1. So we're finding the cosine of something that gets us 5 over 7. But really, we're just going to do this on our calculator because it's not a nice spot on the unit circle. It's not a spot that we have already sectioned off and memorized. Okay, so that one on your calculator, that's the value that you get when you type in the second cosine of 5 over 7. Okay, so this part up here, this original equation, that's what you type into your calculator. And then round your answer to at least 4 decimal places. Okay, now this is our last example for today. And here again, we have the inverse of an actual trig function. So we have the inverse cosine of a cosine. So this is where we're going to use our cancellation properties. Okay, so let's go back and look at these for a moment. When we have the inverse cosine of cosine, that x value that they gave us has to stay between 0 and pi. It's our range values. Okay? So if it is between 0 and pi, then we can just cancel. If it's not, whoops, if it's not, then we'll have to go through the whole thought process. So let's take a look at our first value here of 2 pi over 3. We want to say, okay, is that between 0 and pi? So on my unit circle, here's 0 and pi, and 2 pi over 3 is right here. Okay, so it's already between 0 and pi. It's somewhere in between them. Doesn't have to be exactly in the middle. So for this one, it is between 0 and pi. So I can just go ahead and cancel. Ka-choink, ka-choink. And I'll get 2 pi over 3 for my value for x. Okay, now for part B, I want to find 5 pi over 3. Okay, and I want it to be between 0 and pi, but 5 pi over 3 is over here in the fourth quadrant. So he's not between 0 and pi. So I can't just cancel out my inverse cosine and my cosine and get 5 pi over 3 as my answer. Okay, so let me write down 5 pi over 3 is not between 0 and pi. So that means I can't cancel. So I'm going to have to evaluate the cosine of 5 pi over 3 first. So again, if you have this memorized, or if you're looking at your unit circle, you want to find 5 pi over 3. Think of what the terminal point is for 5 pi over 3. Think of what your x value is in that terminal point. Okay, 5 pi over 3. Here's my terminal point. The cosine value is the 1/2. So really, I'm doing the cosine to the -1 of 1/2. I'm doing inverse cosine of 1/2. Now, 1/2 is between -1 and 1. So once I rewrite it, now it's kind of like the examples that I just did before. Okay? So if you can't cancel stuff, then you just evaluate what's in the parentheses, and then you evaluate it like we've been doing our other examples. So 1/2 is between -1 and 1. So I'm going to rewrite this. Cosine of something is 1/2. Now again, I have to stay between 0 and pi on my unit circle. So I need the value, the radian value, that has a cosine of 1/2. Okay, so here's my positive cosine values. 1/2 is pi over 3. So x is pi over 3. Okay, so remember that your x values for both of these sines and cosines, okay, they have to stay between -1 and 1, but for sine, we're staying between -pi over 2 and pi over 2 on the unit circle, and then for cosine, we're staying between 0 and pi on the unit circle. Okay. So again, sines, we're staying on the right side of the unit circle, first and fourth quadrants. Cosines, we're staying on the top of the unit circle, the first and second quadrants. Okay, so practice these problems. Again, it's a lot of little detail, a lot of little steps, but just remember that you have to stay between those domain and range values. I have all the solutions worked out in the binder in the classroom. Check the odds in the back of the book, and if you have any questions, come on in and see me before school.